Hi, this is Dr. Taheri, and the purpose of this tutorial for my APSC171 students and whomever actually is interested to learn SolidWorks is a kind of providing a type of teaser to motivate and encourage students and beginner users to go more in depth to SolidWorks. I have used other engineering drawing softwares, and I have to admit that each engineering drawing software has its own advantages and disadvantages. However, I found SolidWorks a very user-friendly, capable, sophisticated software that it become very popular among engineering students, graduates, and industry. Before I start, I would like to actually highlight the point that why is it important for engineering students to learn how to use a drawing software. The fact is that in any science field, any career, people belong to the group. They have a particular way of communicating among themselves. The lawyer communicates in a different way, which is perhaps uh, less familiar for the rest of the population. So, as doctors, psychologists, and engineers are not exceptions. Engineers uh, communicate with each others and conveying the details through engineering drawings, schematics, charts, and this is the way that they can convey the details. I often ask my students, can you describe these components by using words in a way that the readers or listeners can visualize it? And of course, they would fail to do that because it's almost impossible. And then I explain to them it's very easy to do that in using engineering software. And this is exactly what I'm going to do now. And again, I'm not going to teach you how to do this here. I'm just going to show you how quickly it's possible. I'm going to create that geometry by simply drawing a base, and then simply extrude that. And again, I don't have any dimensions here. This is simply for just showing you as a schematic. And purposely I'm going to make it bigger than it has to be, and then I can simply modify it in a second. I make those two circles. And there we go. It's almost done. So obviously, as I mentioned, that this is a little too big, and it's very easy to modify the drawings that you have. So simply go here, and this is where you actually plotted this half circle, and you can make it smaller. And here's done. I may add a little bit of fillet here just to make it look better. I actually use the size maybe 2 would be more appropriate. I do all the edges here. And that's it. So this is as far as the geometry goes. We build it. But also is much more into it. Like for example, I can go and select the material here, uh, and let's just, for the sake of argument, let's choose 1020, which is low carbon steel with 0.2% carbon. And then I can simply go here to evaluate, and for example, for mass properties, I know exactly this is about 9 kilograms, and this is the volume. I know this is the center of mass, and then the principal axis of inertia, and so on. I can also go and I can say, well, what is this area, the surface here? So I can simply go and select, just go here, this area. Sometimes it doesn't do it. Let's go here, or it's it here. Oops. One more time here. Why? Okay. Yeah. Here you can see that when you click correct, you will get this area, and then you want to add this area. You can add it, and you can simply add more. You just magnify. This is what we have here. So it's also the area that I selected already. I can add this one into it. You can see it adds more, and you can add more into it. So this is one of the reasons that you can perhaps use this evaluate tools. But maybe you can go a little further, and you can say, well, I want to use some kind of load analysis. I have to admit this is maybe a little bit more advanced for first year students, obviously, but I always tell them you don't necessarily have to study the roots in order to pick the fruit. So just pick the fruit now, and then for studying the root you will have time. Assuming I would like to apply some kind of load here, I go to simulation analysis, or simulation express. So start with defining a fixture. So let's say this is fixture, this is fixed, and I'm gonna go here and I'm gonna add force to this side. What is the amount of force? The amount of force would be, I would say, maybe 30,000 Newton. Materials already selected. I go and run the simulation, and the simulation of course depends on how complicated the geometry is, what are the complexity of the load, and what is the mesh size. It could take a few seconds like this particular case, or it takes maybe days, and again depends on how fast your computer is. Sometimes for advanced simulation they use parallel computers. So obviously this is how it looks like, and I have to say that this is not realistic. It looks like a rubber, but that's not important. What is important is that you can go here and you can see the displacement, and you can see that these values are, let me again here, these values are very very small per millimeter. How much deformation that you have, how much bouncing effect they have, and then also you can go and see the distribution of the stress, and you can see right here, here is the area with the highest stress, and this is what we expect because it's a high kind of rise, is a sharp angle. But of course in this particular case we have to bear in mind that I use the factor of sales factor of 1, and that's not very safe. Depends on what component is this and in what working environment it's working. If this is a component that has to be in part of airplanes and or bracketed used to hold engine or something, so you don't want to put the lives of hundreds of people on air. Therefore you have to use maybe something factor of maybe 3. And as soon as I use the factor of 3, then here you can see that you get some major problems here. And that means that this material is going to fail, this component is going to fail. There are 3 different approaches to solve this problem. Either I have to modify the geometry. I can show you, I could have add fillet here, and that would have perhaps significantly helped the situation. I can reduce the load, but first these two sometimes is not possible. And I guess if this is the case, then the third excuse me, the third option would be changing the material property, change the material itself. And now in this case I can use, instead of 1020, I'll use 1045, and this is medium carbon steel with 0.45% carbon. It's a much stronger material, and for that I will run the simulation again, And after I run the study, I will simply see if this is happening again. Let me just go here, and you can see here it's much smaller situation, which this can be actually simply resolved by, as I mentioned, adding that fillet. I would say the size of maybe 6 in this area as well as in this area. And see here why doesn't this. Oh, it's kind of strange. We'll do it again. Oh, I already have a fillet here. Sorry, I already made a fillet here, so we can do 2 fillets. So in this side, he actually was kind of interesting because he had a fillet. We didn't see this didn't happen here, and I can add another fillet here, or I can simply go here and modify it. And you see that I can remove this one here. I remove this fillet, and for these 2 areas, I can maybe use a different fillet size. I use maybe 6 here, this one, and this one, and here it helps it. So that's one simple load analysis. Just close this one here. Let's open another new file. So, and here I want to do something again different. Now here, sometimes we use other software. Sometimes it becomes complicated for some simple drawing. For example, if you want to make a complex spring shape, just for loading spring, it's not that easy. So, but however, SolidWorks makes it very easy. And you go to curve, and then you go to helix, and you make a variable one. So from 1, and I put it here, maybe I would say 10, and make this one to be 500, and then the next one 100, 20, and 100. That's all I need here. So by this simple action, I made a helix shape like this. And now if I want to turn this one to an actual spring, I go here and I select a new plane, and then I make a drawing in this new plane, which is here. A simple drawing which is shaped like this, and then I connect this to this piercer. Done. And then I go here to feature and do the boss extrude, and simply I run it like this, and then I would get a rather complex spring shape. Then I would say, well, this is good. I can run actually that load analysis, but it takes much longer time, especially because of the fact that I am running this screencast, which consume a tremendous amount of my RAM. But now if you want to make some changes here, assuming that this is working in a high temperature, and then you want to run some kind of fluid inside this coil, so all you need to do is you go here and you make modification in this circle here, and add another circle in the center. And by doing these simple things, of course, there are lots of calculations. You have millions of calculations has to be done in order to kind of pass it through, but it will do it perhaps very easily, and it shows that how user-friendly SolidWorks is. And again, in this particular case, unfortunately, because I'm running this screencast, it should have taken this long. Without that, it may take about a minute or so. But now, well, less than that, it was in 10-15 seconds. Let's just wait for short while, and hopefully it gets to there. And if not, I have to perhaps stop it. There we go. So here you can see that now I have this kind of coil here, and it did it very simple. I want to make another example here, make another file, and this is more kind of like a fun. Let me see if you can guess what this component uh, turns to be. So a simple shape I make like this, and then all I do in revolve, and here I make it 0.3 here. It turns this things to kind of like a can shape. Let's do a little simple fillet here. I would say maybe 2. I make it 1. 1 is good. And this one as well. There we go. I go to this face, and let's make another tangent. Let's see if this is all tangent. And then I select this point, and extrude cut. So here I made a simple can. Now if you want to be a little fancier, you go here. I'm not going to use the Budweiser, not tonight. Use Red Bull, and you simply drop it here. Oh, I brought it in top here. Should have done that. Let me cancel this. It's a little tricky, so let me do it again. And there we go. See, you have Red Bull here. Simply made it so fast and effortless. You can change this size here. You can make it smaller, bigger. You can change the direction and anything else. And you see how versatile it is. And let me just do another example. Again, another teaser. Of course, SolidWorks is designed for 2 and 3D drawings, and you can create advanced mechanism using 3D assembly and 3D making and so on. But sometimes it's easier to start with a 2D. See, this is working in 2D, and then you extend all drawings. SolidWorks has made it very easy. Let me start by a very simple mechanism here. The tangent here. Only thing is this is a tangent. We have a tangent too. Let's connect this point and this point, merge together. Yeah, and I'm gonna fix this point as well. So what SolidWorks can allow you to select this one, and you go and make it as a block. So it's all become one block, this shape like this. The next thing I want to do, I make another drawing here, shape like this, circle, and maybe add a little handle here, tiny one. I select this one too, and I make it block. So, and then I'm gonna go here and let me just rebuild this, and I go to let's finish this one here, and I go belt and chain, select this, and select this, and all of a sudden I create an interesting relation between these two. And now you can see that how easily by moving this is going to move. Let's just go a little further, and I'm just going to make a shape like this and something like this. Oh, like that, back here. Yes, 1 point, 2 point. I think I made it. No, delete this. Yeah, I made an unnecessary relation here. So this is done, and then I go to make the actual. This is good. Huh? And this one. Actually, this is not exactly what I want. I want 3 points. This, and I think this is good. Yeah, so because it's touching more than 2 points, it gives this error message. Wow, sure there's something we can do about this. Go back. Yeah, I have to magnify that. That's good. So because if you don't select it correctly here, it gives you an error message. Now I go here and I trim this, select this, select this. This is done, and I'm gonna make this one as one block. Let's do a few more things here. I want this point and this point to be vertical. I want this to also be vertical. And then I do something very interesting. Let me finish this one here, and I go to first block. I want to edit the block, and I want to create something that's called path. I select this, select the chain, right click again, select the path. Path is selected, and then when I go and modify this sketch, I want to select this and this, and I want to be tangent. And see what's gonna happen here now is an interesting relation I have here. If I rotate this one here, let me just go, and what I should have done here also, I should have fixed the center of this. Let me just go to here, and I could have simply select this and fix it. Now it's fixed, and now you can see that I can simply move this easily, and this cam is gonna move this ups and down. So you go up and down, and of course this is not for animation, obviously, it's just for showing how it works. And I have actually another example here. This is my part here, and this is almost like having 4 of them working. So we have 2 vertical and 2 horizontals. It's almost like could be kind of an engine. So each one fires one after the other one, We'll also use that as a forge, forging, or a switch. So that's kind of interesting to show how SolidWorks will do the job here. And we can go even more advanced and make kind of like a robotic arm. Anyway, I hope this has provided you a kind of a little teaser type of thing to get your feet wet and start working SolidWorks. Thank you very much.